How does the Catalyst package support scientific inquiry?
Well, in Catalyst, first and foremost, we wanted to reflect all of the different levels of inquiry that would be possible in the new junior cycle science course, so as to encourage students not just to learn about science, but also to become independent investigators. The science investigations template in the Catalyst portfolio supports and scaffolds the students' progress through many genuine opportunities for scientific investigations in the textbook. The opportunities for scientific investigation span the whole spectrum of inquiry, ranging from limited, structured, guided, up to and including open inquiry, which we hope over time, and with the help of course from teachers, will allow students to be more creative in the way they approach investigations and solve problems. In Catalyst, we are also acutely aware that scientific inquiry doesn't simply revolve around experimental investigations, and as such we've also provided students with multiple opportunities to engage with what we describe as minds-on activities at the various levels along the spectrum of inquiry. In the context of limited inquiry, the question and method are pre-directed, but the outcome is unknown to the student. As an example of limited inquiry, in a scientific investigation in chemical world, students are provided with a set of pre-directed questions and a method that enables them to investigate the statement that solids, liquids and gases all have a mass. As an example of limited inquiry, in a minds-on investigation in biological world, students are provided with the details of a genetic cross and through a series of scaffolded questions reach an outcome related to the inheritance of gender. In the context of structured inquiry, students are led sequentially through a series of steps and as a result construct knowledge. As an example of structured inquiry in a scientific investigation from Earth and space, students are led through a series of steps as they make and record observations related to a model of the Earth, Sun, Moon system, and as a result they construct knowledge about the seasons and eclipses. As an example of structured inquiry in a minds-on investigation from the biological world, students are led through a series of questions related to the 5-digit limb, and so construct knowledge in respect of evidence for the theory of evolution. In the context of guided inquiry, questions are more open. Students may be asked to provide an explanation or to explore, however they may be guided in terms of equipment to use, etc. As an example of guided inquiry in a scientific investigation from the physical world, students are guided in terms of equipment to use for investigating the physics of seatbelts. However, the questions posed encourage students to make predictions and explore possibilities related to analysis of data, communication of findings, and evaluation of that investigation. As an example of guided inquiry in a minds-on investigation from the chemical world, students are asked to prepare a class debate to argue the statement Ireland should consider hydraulic fracturing to meet growing energy needs. In the context of open inquiry, students volunteer their own questions to investigate and develop the methods necessary to satisfactorily answer those questions. As an example of open inquiry in a scientific investigation from the chemical world, students are asked to develop their own method to investigate the effect that different salts may have on the rate at which an ice cube melts. As an example of open inquiry in a minds-on type investigation in physical world, students are afforded the opportunity to conduct open research to answer the question, medical technology, good or bad? The different levels of inquiry are not discrete, and different activities can have different levels of inquiry integrated into them. We want to assure teachers that there is no suggestion that there is an improvement when going from left to right along the inquiry spectrum. However, it would greatly facilitate students in having a meaningful engagement with the nature of science if they were given many opportunities to inquire in the classroom. Students need frequent practice to develop their inquiry skills to a point where they can conduct their own investigations from start to finish. We believe the Catalyst package provides students with sufficient content for thinking in order to allow them to progress along the inquiry continuum or spectrum. By including many activities to enable students to experience all of the different levels of inquiry, we expect that students will not only successfully learn about science, but also become independent investigators over time, and so be adequately prepared to undertake their own extended experimental investigation in second year. As practicing teachers, we're all acutely aware that learning by inquiry can pose teething problems when introduced to students initially, and it can also be time consuming. And as such, we have provided a detailed support for all of the different activities, tasks, investigations in the teacher's resource book, including suggested methodologies, points to note, suggested extensions throughout. As an example of the potential use of the teacher's resource book, a teacher could, if deemed necessary, present students with the suggested methodologies in order to provide extra guidance during a more open inquiry type investigation.